We'll have new topic today, scripting language. So Flume and Pig, this two are pending. Once this is done, we're hoping to complete this week. Let's see how many things are completed. So the topic name is Pig, and this is a scripting language. Okay, Pig is working here as a scripting language and behaving as also a scripting language. So I can call it's a scripting language which is designed by Yahoo, which is designed by Yahoo in early 2010. Later, they donated this pig to open source Apache, and today we can use them freely with Hadoop environment, obviously, because pig is also an ecosystem of Hadoop. Now, what is the difference between pig and MapReduce? Because pig is a scripting language and it can do all the tasks, all the activities it can perform, which MapReduce is doing. So all the responsibility of MapReduce can be easily transferred to Pig. Now, when I'm saying MapReduce and Pig both are designed for same purpose, then why do we need two different tools? MapReduce is there for programming language support. People who are good in programming, they work with the MapReduce. People who like more on a scripting, they can work with Pig. So quickly we'll differentiate between MapReduce and Pig. Now MapReduce, some common functionality we have. This is also for high latency data. This is also for high latency data. Whatever data is stored in HDFS can be processed. It provides us local mode also. Here we have just one mode, which is HDFS mode. Then second difference, this is for OLTP. This is also for, by the way, OLAP. This is also for OLAP, online analytical processing. But the main difference between these two language is this is designed by Google. If I take this point as a difference, and a second difference is MR is created for programmer, people who are good in programming language. Pig is good for people who like scripts like Oracle, SQL, MySQL, cell scripting. So wherever we need scripting, Pig is also working as the same. Then MapReduce doesn't have any inbuilt functions. MapReduce is not, it is not having any inbuilt functions, so I'll call it's not applicable here. We will have to create our own function. However, in Pig we have got so many inbuilt functions. Now, using this inbuilt functions, we can achieve many output, many requirements we can simply calculate using this PIG. But one interesting point is here, we call Pig is faster than MapReduce. Okay, there is one note, Pig is faster than MapReduce. Now the question is, when we say Pig is faster than MapReduce, so what Pig is using, what execution engine this Pig uses to submit its query? So Pig is submitting its query because I call Pig is the ecosystem, right? So when I say ecosystem, Pig has a two dependency. They're writing data to HDFS and they're processing that data to using their Pig execution model. So Pig is giving you one language which is a Pig Latin, but Pig is submitting its query, right? Pig submit its query to MR execution engine. Now this is a topic of discussion, execution engine, because if MapReduce is submitting all the query of Pig, then how come Pig is faster than MapReduce? because pig is ultimately dependent on MapReduce only. So when I write this point, pig is faster than MapReduce. In which context they are faster? We need to know this part. They're faster in which context? In processing the data, or their development time is less. So yes, peak development time is very less, because in MapReduce, if I want to develop something, okay, let's write MR development. If you want to create a jar file, if you create a jar file using MapReduce or using a Scala or using a Spark for that matter, right, using IntelliJ, how many total steps are there to create a jar file in development environment? So first we need a data, which is our input data. After this input data, we create an input split. After input split, we go with the record reader. After record reader, we send this to mapper. Then mapper will initiate with the map task. Then after map task, they have partitioner. After partitioner, we are sending this data to shuffle and sort, shuffle and sort. After shuffling and sorting, and by the way, there is one optional step called combiner. So if you need combiner, you can use it. After shuffling and sorting, we have record writer. This is oftentimes not displayed and written in textbook. Record writer, and after record writer, we have reducer. This is internal story of MapReduce. After reducer, we have the final output. So we know input and output is stored in HDFS and HDFS. Then this internal operations are happening inside resource manager and node manager with the help of those. So this is the MapReduce development, typical how we create it. After this reducer output, I create a jar file, copy to server, and we check it whether this MapReduce can deal with the data or not. What is the development task or development steps of pig? Pig doesn't follow this. Pig says pig there are two environment for pig. Two environments given for pig. First environment is local environment, and second is a first is a local environment, and second is the HDFS environment. To open this local environment in pig, we will write in a terminal of our Cloudera. Okay, we'll be doing this practical after getting few theoretical points. So in this terminal, I will use pig-x local. In my normal terminal, I will write this pig-x local, and this pig-x local will open one cell, and that cell is a grunt cell. Grunt is a name, and this is cell for pig. Just like Hive has its own cell, HBase has its own cell. Similarly, this pig is also having its own cell. Now, whatever pig queries we have, we can submit this in grunt. Now, make sure one point which is very, very important. When we call local mode, what do we mean by this? Local mode means your input file is there in local file system. The data is present. Data is present in local file system. That's what it means when I say local. So this limitations, remember, when I want to open HDFS in terminal, I will write pig-x map reduce or just pig. Okay, pig-x map reduce or just pig. This will open again one cell, and that is also a grunt cell. Now, what is the limitation or requirement in this second type? Data is present Our data should be present, we should write here. Our data must be present in LFS. Here I will write data must be present in HDFS, in Hadoop distributed file system. So this is two different environment in PIG. We'll see this each environment in some time. Then we have a data types. In Pig, we have a data types, and this data types is again categorized in two different types. First is a standard data types we can call, or primitive data types we can call. Standard. The standard means the regular one, which we use more often. And second one is a complex, just like the same category we have in Hive also, primitive and complex. Standard data type means we use that integer, long, float, double, date, boolean, timestamp. Also, those things we can use here. Date, time, stamp. Date I need to see, boolean. Now you wonder, we are not using string here as a data type. String we are not using. Then what we are using for text data, if I have any text character. So for text data, we uses char array. Char array stand for character array. So this character array we are using for string data. Okay. Why we are using char array or character array? Because I'm not dealing with one line or two line. Maybe I'm dealing with 700 line, 10,000 line, 5 million line. That's why we need this char array. So whenever you need a string as a data type, make sure you're writing this character array. Then complex, we have tuple. I will tell you what is tuple. Tuple we have, then we have fields, we have bag, and we have map. So you'll find a couple of new name like field and bag. There's a new. Tuple is a collection of structured, unstructured, any data. So a set of contents I can call a tuple, or a set of row I can call a tuple. In a single row there are multiple data, right? We have seen this tuple in Scala also, that how Scala deals with tuple. When I have mixed entry in any variable, I have data from all the all the data type, then I will call that is a tuple data. Filled in mag and map, we will see this. So these are two different data types in Pig, but Pig uses one by default concept of data type also. If you're giving data type, then it is okay. But if you're not giving, by default, byte array. You've seen this byte array in HBase also. By default, byte array is data type of Pig variable. So if your variable is not having any data type, okay, this will contain, so variable I'll not say because those are fields or arguments. So by default, byte array is data type of Pig. These are the data type which you can pass. This is the by default one. This is about data types. Then after data types, Pig has a concept of plan. Okay, plan, will understand this in detail. And here I'll be referring DAG also, directed acyclic graph, how directed acyclic graph are plotted. Now this plan, we will create in 4 phases. Whenever I create anything in Python, in Pig, we define that based on a plan. So first plan will be the logical plan. I'll write pointwise. First plan is a logical plan. Logical plan means, what was DAG? If you remember, what was DAG in Spark? DAG is a directed acyclic graph. And directed acyclic graph is, we can write one variable, we can do some processing on that variable, In the same variable, I can refer it again to next phase or for other variable, right? It's like I have A here, I have B here, I have C here, I have E here. These are my steps. I'm doing operations on this stage. Four stages are there. And these stages are nothing but my tag operation, because after A, I'm not repeating this A again. After B, I'm reading directly in C stage from B only. I'm not again processing B. And this is how it looks like. So DAG means they're not completing the cycle. If I go from A to B and from B again I come back to A, this is not a acyclic, this is a cycle. I send something, then I'm getting acknowledgement here. This is a cycle. In DAG, we do not complete any cycle. That's why it is known as acyclic graph, acyclic process. So logical plan I'll be creating using the same method, DAG method. Okay, so many keywords we have in Pig, they are rich in terms of keywords, so we can use those keywords. Then after logical plan, we have new logical plan. So logical plan is not doing anything if you get it this point. This is like a lazy. If I enter it, it it gives me one plan, but it has not computed yet. The computation is not happening immediately. Computation will happen when we ask to compute it. Similarly, we have transformation and action keywords in Spark. In Pig also, we have keywords for this activity. Which one will be giving me output? Which one will be just creating a plan? So logical plan, new logical plan. Then third one is a physical plan. And the last one is map reduce plan, MR plan. So these are four plans. Whenever we do anything in Pig, these four plans will be there. Okay. How we will create this plan? Using obviously these steps, different data types we will use, different mode we will use to create a plan. I'll try to process one file. Okay, maybe a temperature or maybe a any string or substring data from there. Now after data types, after plan, we said Pig is submitting its query to MapReduce. And why MapReduce is slower than Pig? Because in Pig we don't need these stages. We don't need this so many stages. In Pig, I will open my local or HDFS mode, and then from there I can directly process the data. No need to do input, then and that is splitting, then mapper, all that operation we don't have. When I submit any query here, then that query is going to MapReduce, and then internally MapReduce flow is there. After this plan, we'll open now our Cloudera and we'll see some of the query. Okay, so this is my Cloudera. We'll wait for some time. Once this is open, I'll start writing my queries there. So structured, unstructured, semi-structured, all types of data we could see in this Cloudera. Let this open first. This is open now. We'll check this terminal, and here we will write pig. I'll test both the mode, local and HDFS. Okay, CD desktop. You can call it from anywhere. Where is the setup? If you want to see that setup, it is inside user lib and pick. This is the location. And inside this configuration, we have one site XML file for pick. This is the properties where we set everything, all the detail. Okay. By the way, this pig is by default available in GCP also, Google Cloud Platform. You just have to type pig x local, it should work. Now, the same, I'll call pig x local. This is the command we have written to open in the local environment. What is the requirement? Data must be present in local file system. So here your cross communication will not work. If you open a local environment and then you're trying to access HDFS data, it won't support. Same case goes with HDFS also. If you're in HDFS mode and you're trying to access local data, it won't work. So they will only access their own platform data. Now, can we enter this? We don't have any separate daemons for pig. It is working on Hadoop daemons only. That all 5 daemons: name node, data node, secondary name node, resource manager, and node manager. Because ultimately this query is being submitted to okay. I think it's connected again. So there was some electricity issue. So now after this line, we'll read the file again. So this is my local mode, and in this local mode I want to use pig keywords. Can we write some of pig keywords? So these are the pig keywords, and we'll be using this pig keywords. So first keyword I'll use as a dump. Okay, first I'll write the name, and from that name we'll understand what this keyword is doing. Remember one more point: pig is case sensitive. Case sensitive means whatever query you are submitting, it has to be with matching case. If case is not matching, it will throw you exception. We're checking the first keyword, load keyword. What this load is doing, this load will load data to my variable using pig environment. Okay, so load is for loading the data to a variable. Then second stage, this is not doing any action. It's like DAG program. We have seen the lazy computation. There is no action taken and sending data to CPU. They're only referring to some point in RAM, in memory, and that's it. They're not sending it to RAM. If I make something as lazy. After loading, I did not see the output. To see the output, I will use this keyword, dump. So dump keyword will help us to dump the data in console. Okay, as the name suggests, dump. This will dump the data in console. Console of what? Grunt cell. We can see that data. So this will display record. This will display the record. Then third operation is store. Store we are using to store the data, because this is just displaying it. It is not storing anywhere. This will physically store your data at some location, physically store. and that location must be from the same environment. If you're in local file system mode, your data should store in local, otherwise in HDFS. So while storing the data again, we'll have to remember it. There are so many other keywords like union we have. Okay, union, then union all we have, then limit we have, then all splitting we have, average function we have, group function is there, co-group is there, co-group is also there. Okay, there are so many other keywords like if I start writing, there are 16 to 18 popular ones. Okay, now we'll see how this can help us. We do even all types of joining also using this pick. Now we have seen the difference between MapReduce and pig in the first file. But one big question, which one is more robust? If I check they are powerful, which one is more robust and strong? So anytime programming language support, any module is having that, uh, those are much faster and better than the scripting language. So if somebody asks me Spark is better or not, I'll say anytime Spark is better because Spark can deal with multiple languages. So we'll write one more point here. This MapReduce is a robust programming model. However, it is designed for low-level programming model. Okay, but this pig is not robust. It's not robust. Means if I want to do some customization on pig, it is difficult. If I want to do some optimization in MapReduce, we can do that using MapReduce. Okay, but in pig there will be some kind of issue because we are using the ready-made function. Here we are creating the function. Remember the difference? Here we are creating the function using our logic. Here we are using ready-made function. So what I can do in MapReduce is definitely complex, but all task or all activity which I'm doing in MapReduce, especially for function creation, I cannot do that in pig because therefore ready-made functions. Use the function which is already available. Now, if you ask, can we create our own function in pig? I'll take that later. On function means you want to talk about user defined functions. So this is my local mode and I want to read a file here in this local environment. To read the file, first we will open again one cell, and from this cell we'll read any file. So let's see if we have any in desktop. There are so many file, email.txt, then census report.txt, vehicle. I'll read any txt file. Let's say I want to read the census file. They are complex data because this is one country. Then there are some delimiter, which could be space or tab. I don't know that currently. I'll check. And these are my second result in key and value form, year and some number, again year and some number. So we have seen this data, how to store this in Hive. This was exactly for Hive map, complex data type map. I want to read this data from local environment in pig. Copy this path, and in local environment, you'll have to write in the left side, what I'm saying is up to me. Okay, so you can use anything here in the left side. I'm saying AB. So I said AB is equal to, okay, left variable could be anything. AB is equal to, now you will use a scripting syntax load, and here you'll have to write a path from where you will read your data. And this path is my home Cloudera desktop, this path. And here we will read this file, census report.txt. So let's go here and give this path, census report.txt. Now After this, do we know what is the delimiter of the file? If you know delimiter, you can write it here as biggest storage, but if you don't know the delimiter, uh, you can keep by default. As in, you should not write the delimiter. If I know delimiter, I will use the other method. Currently, I don't know, that's why I'm not using delimiter. And column name we define here at runtime. Just like in HBase, column identifier we're defining runtime. Here, while reading the file, I will define their column name. And how can I define their column name? It is this. Suppose you want to store this whole line in one column, you can do that. If you want to store this complete line in two columns, you can also do that. So let's just store this in two columns. First column will keep this one, and second column will keep this one. And we know the delimiter in between this two field, So I will write using, whenever you know delimiter, remember this, which I'm writing, using pig storage, and within this single quote, we will write the delimiter, which is tab. I'm also not sure. So I'll open this file, sense file, and from there we will check what is the delimiter. Delimiter is coming as tab. Country is going to one column, and temperature, year and their population in million will go to another column. And those definition we will write here in pixel. What I'm writing is known as a pig Latin. Okay, this query is known as a pig Latin, and this pig Latin I'm writing inside pixel. Now, column name, can I write country? And colon, what is the data type? You want to give char array because this is a string, comma, second column. Now look, if I do not write here this data type, so by default also we have a data type concept in pig. This is what is the by default data type if I don't give anything, but currently I'm giving it. I'm giving country colon char array. Then second column is year. Let's say year by population. And you don't want to give any data type because you don't know whether it is integer or double. So you keep this blank and enter it, semicolon. Now this is the query which I have written. AB load the file using pig storage. Now two questions. When I enter, one second. When I enter, so this is the complete line. When I enter, I did not get any output, which means this is one lazy computation. Can we say this is also as a lazy? Because if you do not talk about Hadoop also, if you go to RDBMS and you submit any query in database, okay, suppose you submit select star from table name, select star from table name. You're doing this in RDBMS. Now, when you run this query, what happens? Immediately you get the output here, right? If you're getting immediately output in next in the console, which means this is going to CPU for processing. If there is no processing, then how will I get this output? So CPU is processing immediately, I'm getting output. But in pig it is not happening due to the concept of plan. Because here currently I have created a logical plan. Because if I give any other file path also, if this file path is not present in my HDFS directory, local directory, if this is wrong path, then also I'll not get any error. Because this is not doing anything in RAM, they're not keeping something in memory, they're only creating one plan. And when I will execute this variable with keyword called dump, when I execute this AB variable with dump, because dump and store, these are the only keywords which will invoke MapReduce. So I'll write here, if I do not write dump and store, then there is no execution of MapReduce. If there is no execution of MapReduce, then I will not get any output. So dump and store, these are the only keywords which will send my query to CPU. Okay, please remember this point. I repeat again. Dump and store, these are the only keywords in Pig which will send my query to CPU for computation. Otherwise, all these keywords are just creating a plan, and that too logical plan, any logical plan. So if I write 10 lines and I do not submit this dump and store, then I will not get anything in my console of Pixel. So dump and store, this two will invoke the MapReduce. We know both the differences, what dump is doing and what store is doing. I will use first dump, and here I'll call dump and this variable dump and AB. Make sure you're using the same case. If this is in uppercase, this is in lowercase, it will not work. Dump AB, they are submitting this previous query to MapReduce. Okay, the MapReduce will start. You can see all the MapReduce task. All details are there. In fact, we have URL also. Using this URL, we can see what is happening. Last we get acknowledgement, and this acknowledgement is giving two information that successfully reading the data from this disk location and successfully writing the intermediate output also to this location, which is a temporary directory. So successfully reading data from here, successfully writing data to temporary. After 5-10 hours, automatically data will be deleted. That's okay. Queries submitted, queries write, and this is my data set, which we have stored inside that column. So you can see here, all my data is stored in this two column. India and USA, this is stored in column 1, and other details are stored in column 2. But I don't know currently how many columns are there. So I can treat this AB as my local reference. And to check this out, I will use function called describe AB. So when I use this describe AB, this will tell me my column names. So my first column is country column, and second column is year by population, which is using by default data type. And you can see this because I did not define any data types while creating this variable year by pop. Okay, we did not run any operation, just loading the file and reading the file. Suppose I want to store this somewhere. Okay, I only want to capture the country, and that too country where country is equal to India. Suppose this is the requirement. I want only to capture this country data and only this India country data. So can we write a query here? We can say AB, then only country we are saying, right? So country is equal to filter. I can try this filter operation. Filter AB, filter AB, where country is equal to India. So maybe we have some of AB dot I'll try. Some syntax I need to check in Pig. How can we write this query? This is the same query we said we want to store the country where country is equal to only India. I'll check this in Pig. Some syntax are different, so that syntax we need to check. Suppose I will only store uh, this file, so I'll use a store keyword here, and in a store keyword I will use this previous variable, which is AB. So store AB, and where will you store this? Store AB into. Currently, we are in local file system. So I'll give a path of local file system. Home, Cloudera, desktop. And in desktop, we will give this file name, my underscore file. And that's it. My underscore file dot txt, semicolon. What will happen? In this step, whatever I have written, the output of this AB step will store in this line. And we're not doing anything here in this AB. We have just loaded the file. Let's see how this store will work. This is again invoking MapReduce. So two keywords, dump and store, they will only call your MapReduce. Other keywords will not be calling. Other keywords are only creating a plan. Now we will go to this directory and check the output, whether the output is present or not. So success we are getting as acknowledgement. Go to this directory and open your my file. My file is a directory. Now, if you go inside this directory, we have two files, part and success. So part is output because we can see the size also, 68 bytes. And success is just an acknowledgement with a 0 byte size with some data. So this is an acknowledgement we have seen in scoop also. Whenever we do any job, any operations, our output comes in this format. VI part, and this is my data set, how my data is looking. Now, any queries, we'll check that. I'll open a file and based on that file, we will do operations. This is a local environment. Now I want to do the same thing in my HDFS environment. If you want to do from the same cell, it won't work. And that's why we will quit from here. Actually, exit works. I think quit works here. So we'll quit from here, from this cell, and we will type now pig only, because we know this pig will take us to HDFS mode. But before HDFS mode, I need data in HDFS. So can I check any data in HDFS? HDFS, DFS, minus ls, and slash. So we have the file, so many folders name and files name. And maybe I want to read any typical TSV file. You want to read this file. I have isro pslv.tsv. Give this name isro underscore pslv.tsv and caret. This is the data. Now type here in this environment, type pig x local. Sorry, not px local, just your environment name. So here we'll type pig, this pig, because this will take to HDFS. Now here is restriction. My input must be present in HDFS. So file, left side again, I can write anything by the way, left side. One space is there, and again one space I will give after this. Don't write immediately after this. Some error can come otherwise. So make sure one space, then load. What is the file path? It is stored in home directory of HDFS, and this is the file name HDFS DFS minus ls slash. Give this file path, copy and paste. We know the delimiter, so TSP means tab is delimiter. We will use again using. Look, if I'm not giving this using, then it will take by default delimiter as a space. Space is a by default delimiter. So if you're not using by default, it will consider as a space and they will read it as a text file. So if it is not a text file, please write here pig storage, and within this delimiter is tab. How many columns we have? 3 columns are there. So as you can write any column name, C1, C2, C3, or if you want to give any logical name to this column, you can give that also. Cat and ISRO underscore PSLV dot TSV. 3 columns are there: year, number, and city. Okay. So can I call year? Year is integer. Then this I should be lowercase. Year integer. Then rocket name. I'll leave it because it will take by default. And the last one, which is a city. City also I'll leave, so it will take by default by tariff. Now we do not get anything, means this is a point only. If I write different file name, then also I will not get any error. You'll see here. I'm giving pslv1.tsv. There is no file related to this name, but when I try to dump it, that time I will get error. Since this file is not present, now this will tell me file not found exception. That file is not present there. They're trying to compute it, but input path is not existing. I think this is the error. Input path does not exist. Now we will try to give our previous path, which is this, and now if I dump it, so I'll see the output in this cell. This is HDFS environment. So I can read and write my input file from HDFS only. So today we have seen the difference, how we will read any data from local and how we'll read any data from HDFS. So only reading is there. There are many operations pending. How can we transform? How can we process this data? How many functions are inbuilt? Can we tokenize or can we parse our unstructured data also? Because unstructured data is a main task to handle in big data. 80% to 90% data whatever we receive is mostly unstructured. This is 0% completed. In some time you'll see percentage for mapper reducer also, and once this is 100% done, we will see our output. This is my output displaying in the console, and if I want to see the column name, I can use describe function, and in describe I will use my variable name, which is file, and this is the details about that. So tomorrow we'll see other transformations related to pig.